Next problem, reduce the initial value problem y double dash of s plus lambda y of s that is equal to f of s. So, comma y of 0 is equal to 1, y of 0 is equal to, sorry, y dash of 0 is equal to 1, y of 0 is equal to a Volterra integral equation. Y dash of we know that y double dash plus a of s y dash plus b of s y equal to f of s, y of 0 is equal to q naught and y dash of 0 is equal to q1. Then the solution y of s is equal to f of s plus integral a to s k of s comma t y of t dt, where k of s comma t is equal to minus a of t plus s minus t into b of t minus a dash of t, and f of s is equal to integral a to s minus t f of t dt plus q naught plus a of a q naught plus q1 into s minus t. Here a of 0 is equal to 0, b of s is equal to lambda, right? Because y dash term, there is no y dash term, right? Given y double dash of s, then lambda y of s. So a of s is coefficient of y dash, so a of 0 is equal to 0. B of s is coefficient of y of s, so that is lambda, and a equal to 0, right? And f of s is equal to f of s, right? Now k of s comma t is equal to, using that formula, minus 0 plus s minus t b of t, so minus s minus t into lambda, so lambda into t minus s, and f of s is equal to integral 0 to s, right? S minus t f of t dt plus 0 into 1 plus 0 s minus 0 plus 1, that is equal to 1 plus integral 0 to s minus t f of t dt. Hence the Volterra integral equation is y of s is equal to f of s plus integral a to s k of s comma t y of t dt, substituting the values 1 plus integral 0 to s minus t f of t dt plus integral 0 to s lambda t minus s y of t dt. So that is equal to 1 plus integral 0 to s minus t f of t dt plus lambda integral 0 to s t minus s y of t dt. Next, relation between Volterra equation and ordinary differential equation. So this is an alternative approach for an nth order differential equation. Consider the differential equation of order n, d power n y by ds power n plus a1 of s d power n minus 1 y by ds power n minus 1 plus etc etc a n of s, which is equal to f of s. a1 a2 a n f are defined and continuous in the interval a to b, right? With initial condition y of a is equal to q naught, y dash of a is equal to q1, etc etc y power n minus 1, that is nth derivative, n minus 1th derivative of a is equal to qn minus 1, right? Let us take the unknown function g of s is equal to dn y by dy power n. Integrating with respect to s with limit a to s, d power n y by d derivative of y dy power n, right? That is equal to, that is nth derivative of y with respect to y, that is equal to integral, that is equal to g of s, that is we are taking that as a g of s. So then we are integrating with respect to s, limit is a to s, so integral a to s, the nth derivative of y ds, which is equal to integral a to s g of s ds. So this is nth derivative can be written as derivative of n minus 1th derivative, right? dn minus 1 y by ds power n minus 1, right? So the d of x, integral d of x is x, we are using that idea, so you will get d power n minus 1 now y ds power n minus 1, n minus 1th derivative of y with respect to s, which is equal to integral a to s g of s ds plus c, integral constant, that is equation number 2. Using the initial condition, so substituting a, right, dn minus 1 y of a ds power n minus 1, which is equal to integral a to a, instead of s you are putting a, g of s ds plus c. So c that is equal to, because integral a to a g of s ds 0, right, dn minus 1 y of a ds n minus 1, that is n minus 1th derivative at the value a, right. So it is qn minus 1, let it be, right. This implies 2 implies dn minus 1 y by ds n minus 1 equal to integral a to s g of s ds plus qn minus 1. Change of variable s to t, so we will get dn minus 1 y ds n minus 1, which is equal to integral a to s g of t dt qn minus 1. Integrating again with respect to s with limit a to s. So integral a to s dn minus 1 y ds n minus 1 into ds, right, ds is missing, right, ds, that is equal to double integral a to s g of t dt plus integral a to s qn minus 1 ds, right. So that is, again we are using dn minus 1 y, n minus 1th derivative can be written as derivative of n minus 2th derivative, right, derivative d of dn minus 2 y divided by ds n minus 2. So integral of dx, same idea, so dn minus 2 y by ds n minus 2, that is equal to integral a to s t minus a g of t dt, right, plus s minus a qn minus 1 plus c1. Actually in the previous one we are with respect to s only, so the first thing here, first integral a to s dn minus 1 y by ds n minus 1 into ds, integral a to s g of t dt ds only, right, not dt. So that is what we are integrating, ds, integral ds is s, lower limit a, upper limit s. So that is why we are getting, so this is within integral, that is why we are taking, instead of s we are taking t, right, because integration is with respect to t, second integration, right, that is why. So just we change the that is what variable, right, instead of s we are taking t, that is why we are putting dt. And the second one s minus a qn minus 1 plus integral constant c1, third equation. So using initial condition dn minus 2 y of a ds n minus 2, which is equal to a to a t minus a g of t dt plus a minus a qn minus 1. So integral a to a, whatever it is, 0, and a minus a equal to 0, so c1 equal to dn minus 2 y of a by ds n minus 2, that is y n minus 2, the n minus 2 derivative of y at a, so let it be qn minus 2. So 3 implies dn minus 2y by ds n minus 2 equal to integral a to s t minus a g of t dt plus s minus a qn minus 1 plus qn minus 2. Proceeding like this, we will get dy by ds, which is equal to integral a to s minus t power n minus 2 n minus 2 factorial g of t dt plus s minus a n minus 2 by n minus 2 factorial qn minus 1 plus etc etc plus s minus a q2 plus q1, right. So therefore y is equal to, again we are integrating both side, so you will get y is equal to integral a to s minus t n minus 1 n minus 1 factorial, right, g of t dt plus s minus a power n minus 1 n minus 1 factorial qn minus 1 plus etc etc, right, that is nth equation. Multiply 1 to n, right, the previous case we are having dy by ds, right, that is why. So dy by ds, which is equal to this one, therefore y we need y, so integrating with respect to s, right, that is the nth equation. Multiplying 1 to n by 1 a1s etc etc ans and add, so dn y by dsn into 1 plus a1s into dn minus 1 y by dsn minus 1 plus etc etc ans into y. So that is equal to right hand side g of s plus a1s integral a to s g of t dt plus a1s qn minus 1 plus a to s integral a to s s minus t g of t dt plus a to s qn minus 1 s minus a plus etc etc, right? Then nth term ans integral a to s s minus t power n minus 1 n minus 1 factorial g of t dt plus an of s minus a power n minus 2 n minus 2 factorial qn minus 1 plus etc etc plus an of s into s minus a q1 plus an of s q0. Therefore f of s is equal to g of s plus integral a to s a1 of s g of t dt plus a1s qn minus 1 plus integral a to s a2 of s s minus t into g of t dt plus etc etc. Nth term integral a to s an of s s minus t power n minus 1 n minus 1 factorial g of t dt plus an of s s minus a power n minus 2 by n minus 2 factorial qn minus 1 plus etc etc plus last term an of s s minus a q1 plus an of s q0. Therefore g of s is equal to f of s minus a1 of qn minus 1 minus a2 of qn minus 1 s minus a, right, plus qn minus 2, right, minus, because why we are getting integral a to s g of t dt, that is qn minus 1, that is what we are taking, right? So we are substituting that value, right, minus qn minus 1 minus a2 of s qn minus 1 s minus a plus qn minus 2 minus a and s, we are grouping a1s a2s etc etc a and s terms, right, minus a n of s s minus a n minus 2 by n minus 2 factorial qn minus 1